Hello everyone, I'm Karen again, and I'm going to be presenting on 14.8 to 14.10 with Professor Tang. So, the first thing she talked about was the Gibbs Free Energy. Gibbs Free Energy is represented by delta G. It determines spontaneous reactions. It's important to note that at zero, equilibrium is reached. So zero meant like delta G equals zero. And when we have reversible reactions, delta G is always negative. We also have spontaneous reactions, which means that they will occur on their own only when we have reactants present and not enough products. So the reaction will be moving forward. And it's important to note the relationship between delta G and K. Whenever delta G of a reaction is negative, the equilibrium constant is greater than 1. Any reversible reaction with an equilibrium constant greater than 1 is spontaneous under standard conditions. So again, this is just another way of saying if we have K is greater than 1 and delta G is negative, that means that the reaction is spontaneous. So now let's look at the equations on how to figure out the value for delta G and K. So when it's at equilibrium, Q equals K, and we said delta G equals 0. So in order to find the delta G of the reaction, so standard, this 0 is standard, the equation is negative R times temperature, which is always in Kelvin, and the natural log of equilibrium constant. And then we can also find K by setting it equals to E to the negative delta G over RT. So that's basically repositioning the variables in this equation to derive the value of K. So let's do an example that Professor Tang did in her lecture. So basically, they give you this equation, and they want you to figure out the delta G of the reaction. And after you figure out the delta G, you need to find K, the equilibrium constant. You're always given the value of delta G for each specific molecule, so you never have to memorize these values, and you're always given the temperature. So the temperature here we have is 298 kelvins. So let's see how we do this problem. So in order to find the delta G of the reaction, we do the number of moles times the delta G of each product, and we sum them together, and then we subtract the number of moles times the delta G of every reactant. So based on the equation from the previous slide, we had NO2 as the product, so we do delta G of NO2 minus delta G of NO, and we add 1/2 of delta G of oxygen. The reason we have 1/2 here is because number of moles this is the number of moles that is written in the equation. So it's really important to have a balanced equation in order to get the value of the delta G of the reaction correct. So after, based on the equation here, we have 1 mole times 51.3 kilojoules per mole. And these are also the values that were given to us for NO and oxygen. It's really important to note that the values here are in kilojoules. However, when we determine the value for K, we need to convert everything to units of joules. So after you get this equation, make sure to move the decimal point 3 places to the right in order to get the value of joules. So do not forget to change the units. So now that we have delta G, we can try to determine the value of K. Again, we said the equilibrium constant of the reaction is given by this equation. Since we already determined the value of delta G of the reaction, all we need to do is plug in the value of R and T. So the value for R that we will use is 8.314, joules times Kelvin to the -1 times moles. So it's really important to note that the units here is joules and the other unit is Kelvin. So temperature will always be in Kelvin, and when you determine the value of delta G, make sure to convert it to joules because we want the units to cancel out. So when you do that, for this free use example, you should get this answer, 1.5 times 10 to the 6. So another way to determine delta G of a reaction is by using this equation. So it says delta G equals delta H minus temperature times delta S. So make sure to know what delta H and delta S are. Delta H is enthalpy and delta S is entropy. So these have to be for the same reaction. Again, and the way to find delta H is very similar to the way to find delta G and delta S as well. So you take number of moles times the value, delta H or delta S or delta G, depending on which one you're finding, and multiply by number of moles and do product minus the reactants. These values are always given to you. You're never ever expected to be memorizing these values. So now let's relate temperature, Kelvin, temperature, equilibrium constant, and delta G. So you should always know that if you plot the natural log of the equilibrium constant versus 1 over the temperature, you will get a linear graph. So if you have a positive slope, know that this reaction is exothermic, which means it will be releasing energy. However, if you get a negative slope, know that this reaction will be endothermic, which is absorbing energy. And this is the equation that they have that they isolated in order to isolate ln of k to graph 1 over t and ln of k. So this is the graph. As you can see here for this reaction specifically, it's a downward slope, which means it's endothermic, and that means it's absorbing energy. So that leads us to the Van't Hoff Equation, which is temperature dependent because we have two different temperatures here, initial and final temperature. So all that Professor Tang said is that you just need to look at the variables and be able to plug them into the equation. You're not expected to memorize the equation. So always know that R is a constant. You never try to find that. You might be able, or you might be required to find delta H, which is in the equation that we showed previously. And the temperatures are always given to you, and then one of the constants will be given to you. They might play around and ask you to find one of the temperatures and give you all the other constants and variables. So make sure you're able to manipulate equations and do basic algebra. So this is a summary of chapter 14 that Professor Tang put on there. These are all the equations that she gave. So you can that's one way to find delta G. This is another way to find delta G. If you have the equilibrium constant, temperature, and the R, you always have R. Another way to find the equilibrium constant is by doing the concentration of the products raised to their molar coefficient over the concentration of the reactants raised to their molar coefficient. This is also the Hof equation, which is temperature dependent. And this basically concludes chapter 14 for Professor Tang. And thank you for listening.